Today we're going to be talking about the dissolution process. So that means we're dissolving something. So let's start with a couple of definitions that you probably already know, but let's put them up here anyway. So a solution is a homogeneous mixture that forms when a solute is dissolved in a solvent. So here we're going to throw some solvent into this beaker. So the solvent's going to be represented by those blue spheres. And we'll put a solute in there too, which is going to be represented by these yellow spheres. And what happens is over time that solute will dissipate from the other solute particles until it is homogeneously mixed in to the solvent to make the solution. This is a table from your book, table 11.1, which describes different types of solutions. And so the kind of solution on the left means the phase of the solute dissolved in the phase of the solvent, and some examples are given on the right. So the take-home message from this particular table is that the solute can be a solid, liquid, or gas. All right, so you see examples of all three. The solvent can also be a solid, liquid, or gas. And so even though we often think about solutions as mixtures of a solid solute, like sodium chloride or sugar, dissolved in a liquid solvent, like water, there are a lot of other examples of other phases that can be used as the solute or the solvent. Now the wording is kind of important. You see this in here. Okay, so the wording is subtle, but the use of that word in gives some idea about which substance is the solvent and which substance is the solute. And that is because the solute is dissolved in the solvent. So when you see up there carbonated water, which is carbon dioxide in water, that means that carbon dioxide is based on that wording the solute, and water is based on that wording the solvent. So sometimes it's subtle, but it's definitely implied from that wording. Now, sometimes with a solution, it isn't obvious which one is the solvent, which one is the solute. And so that's the next thing I wanted to talk about, is that when all else fails, the way you know which one is that the solvent is always present in a higher concentration. Okay, so you always have more solvent than you do solute. Sometimes they're very close, but the solvent is always higher in amount. Now let's talk about the dissolution process, right? The process of the solute dissipating in the solvent to make a homogeneous solution. So we're going to take some sodium chloride. You can see my salt shaker there. We're going to put some salt in water, which we're going to use as our solvent. Now I'm going to put a ginormous crystal that I've magnified many times, right? So we'll pretend our molecule glasses are on. And you can see that cube, that lattice there that you see with the purpley blue sodium ions interspersed with the green chloride ions, that would represent one crystal. So let's expand on that and look at that magnified view. So this is a picture from your book. And so you can see the water molecules surrounding the crystal of sodium chloride. So what happens over time, water molecules will interact favorably with the ions, right? And you can see that the purple sodium ion in the upper left corner is surrounded by water molecules. And notice the placement, the orientation of those water molecules. The oxygen atom is facing sodium, and that's because the oxygen atom, remember, is partially negative, and that interacts favorably with the positive charge on the sodium cation, as opposed to the chloride anion in the upper right-hand corner is the green sphere, and you can see that the water molecules have their hydrogens, their partially positive hydrogen atoms facing toward the chloride. So over time what happens is the water molecules will come and pull off one ion at a time from this lattice until all of them have been separated. And so if we look over time, that crystal will dissolve and will completely dissociate. So you learned back last semester that these ions, these ionic compounds, separate from each other. The ions separate in water, they dissociate so that the sodium ions and the chloride ions are totally separated from each other. They float around independently, which is why they conduct electricity, right? Last semester you learned that when you dissolve sodium chloride in water, it conducts electricity. That's because those ions float around independently. A couple of other definitions I wanted to mention before we finish, and that is a saturated solution is one that has the maximum amount of solute dissolved. So you can't dissolve any more. So of course if I put sodium chloride in a beaker of water and I mix it up and it dissolves, and then I add more and I mix it up and it dissolves, and I add more and I mix it up and it dissolves, eventually I'll get to a point where I can't add any more sodium chloride. That would be a saturated solution. Now I can add more if I increase the temperature, right? So we've probably learned by making rock salt or rock candy at home, we've learned that if we increase the temperature of our solvent, we can add more solute. So a supersaturated solution is one that is formed when you heat the solvent while dissolving it to saturation, then you can add more. And then you allow it to cool, and forms what's called a supersaturated solution. So if in class, if we have time, we'll do a demonstration with some supersaturated sodium acetate, which is actually the substance that you see there in that picture.